All right, so yesterday we started talking about evolution and the evidence for evolution, and now we're looking at day 2, and we want to talk about fossil evidence and biogeography and how the study of organisms in the land they live in also provides evidence for evolution. So once again, we are on the top learning goal, the one that says explain how the scientific theory of evolution is supported by the fossil record, and then skip a couple, biogeography. Those are the two we're doing today. And then the one we did yesterday was observed evolutionary change. Okay. And that's what we're going to be doing, is using evidence from various aspects of science in order to better understand the process of evolution, how species change over time. Okay, so yesterday you had an assignment where the question was your friend saying there is no point in learning about evolution because it's just a theory, and then you were to fill in the response to your friend. Okay, so your friend's quote, there is no point in learning about evolution because it's just a theory, and your response was either A or B. You said a theory in science means it is supported with lots of evidence. Yay, that's the right one. Theories in science are supported with lots and lots of evidence. There's no such thing as just a theory when you're talking about science. Theories are extremely important in science. Answer B, we should learn about theories because someday they will become laws. No, 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 no. Theories will never, ever, ever become laws. Theories are explanations. So the theory of evolution is an explanation of how species change over time. So looking at the scientific evidence for evolution, we have the fossil record, comparative anatomy and embryology, biogeography, molecular biology, and what we looked at yesterday, which was observed evolutionary change. So we looked at changes in peppered moth populations, and we looked at changes in bacterial populations, and we could see those changes in real time. So that's wonderful. The evidence for evolution occurred in real time. Now, today we're going to focus on the fossil record, and we're going to focus on biogeography. So those are the two areas of evidence we're going to wrap up today. Now, Darwin, we got to kind of pay some homage to Darwin here. Darwin was a naturalist back in the 1800s. That's his young picture. Normally you see him as a bald man with a very long beard. He was a naturalist, which meant he studied nature. And he had an opportunity as a very young person to go on a trip around the world. And he traveled on the ship called the Beagle. And he drew pictures of the organisms he saw. He took notes about everything he saw. And he ended up, many years later, writing a very famous book called Origin of Species. And in that book, he thinks that the environment shapes the characteristics of the organisms, and that traits are passed from parents to offspring, and that all living things are related. So his big ideas are really the foundation for what we understand as evolution and how populations change over time. All right, so we're going to start with the fossil record because Darwin started with the fossil record. When he was looking at the world around him, he examined lots of fossils. Fossils are leftover pieces or impressions that organisms left behind from a very long time ago. And Darwin observed these fossils, he collected fossils, and he read a lot. And one of the big books in the 1800s was by a geologist named Lyell. And Lyell said that in order for these land features to be here, things like the Grand Canyon and some of the mountains, it had to have taken a long period of time. None of this happened in 6,000 years. it had to have a long period of time. So he believed the Earth was an awful lot older than most people were thinking it was. And Darwin was like, yeah, that makes sense because of the fossils that he's seen. So we're going to take a look at a sample simplified fossil record. And on kind of the right hand side, the picture that has all the brown lines in it, we're going to start with that one. The bottom of the slide where it says rock strata with fossils, that's the deepest layer. So the bottom is the deepest, and at the top of the slide, that's the surface. So this is the top of the slide is where you'd be standing if you were standing on the surface. So when you look at the fossils underground, you can see that the deepest ones are the most simple, and then they get more complex as they get closer to the surface. And that's how species change over time. They start with very simple characteristics, and then over time, they become a little more complex. It's a gradual process, and you can see in the picture, you know, just a plain pentagon, pentagon with lines and spikes coming out of it, and then pentagon with line spikes and curvy, longer appendages coming out. So this particular organism changed over time, and it went from simple to more complex. So if you're looking at the fossil record, the deeper you go, the simpler the organisms were. So when organisms change over time, they're going from simple to more complex. And then you have just a easy picture to remember on the left-hand side of the slide with the pink box. And it shows you that there is a change over time in that organism. So the older organisms were very simple, and then they became slightly more complex over time. The ones closest to the surface are the most recent and the most complex. So I think fossils you should be able to get a pretty good handle on. It's something you've sort of seen and heard a lot about your whole life. Hopefully you've been fascinated with it and have studied some, but that's where we are on fossils. So scientific evidence. We just looked at the fossil record, so we know the older ones are deeper, the more recent ones are closer to the surface, and they show how organisms change over time because we can see how the fossils change over time. And then we talked yesterday about observed evolutionary change. And next, we're going to talk about biogeography. So in the next video, the topic is going to be biogeography.